Hey guys, welcome to my YouTube channel. In this channel, I'll be solving LeetCode 75 list using Go. So let's get started. The first problem is LeetCode 1768 merge string alternatively. So this is a very simple LeetCode easy problem. So given two words, we just have to merge them alternatively. So let's just take a small example and let's see how it goes. So let's say we have word 1 ABC and we have word 2 which is PQR. So how do we merge it alternatively? So the expected result is we start with a word 1. Let's take A and then alternate to word 2, pick P, alternate back to word 1, pick B, alternate back to word 2, Q, alternate back to word 1, C, and then R. A, P, B, Q, C, R. So this is the order. And then there is also another constraint. So if one of the strings is longer than the other, append the additional characters onto the end of the string. So basically the second example, if AB is word 1 and word 2 is PQ RS. So res again start with word 1, starts with A, goes to P, alternate back, B, alternate again, Q. So word 1 is exhausted now. So what is remaining? RS from word 2, appended RS. So this is the expected result. Similarly, if there is the third example is if word 1 is greater than word 2, which still is the same. You just have to keep alternating, and if there is any remaining, you just have to append it at the end. Now let's see how to code it. That is the main important part. So I'll create a simple blueprint for coding this. First part is initializing variables, and the second part is alternate looping logic, and then adding remaining logic, and then we just return. So these are the four important points of parts of the problem. So let's just initialize. So the way I'm going to solve this is I'll have a slice, which is essentially a dynamic array in Go. Let's call it res of type byte. So this basically stores each individual byte. It can be of any type. So we have res, and then we have I comma j, which is the looping variable, and then we have size of each of the strings, that is word 1 and word 2. Now we are done with initialization. Let's do the looping. For I is less than m and j is less than n, we take res, and so append method is basically used to append into the slice in Go. This, if you're familiar with Python, it's similar to that. It just appends it at the end of the list. So res word 1 of I, you need to start with word 1 because that's what the problem states. You need to alternate starting from word 1 and then just increment both the variables. And let's go to the remaining logic. So in the remaining logic, we need to, if I is still remaining, that means if the word 1 length is greater than word 2, which means some of the characters in word 1 is still remaining, in that case just append it. Yeah, this is an important point. So you guys might be wondering what this is. So we know from I to M, the characters are remaining in word 1. So let's say if you're familiar with Python or any of the other languages, so specifically in Python, if you have something like this, right? I to j, it means like if you have an array, then consider all the elements from index I to j minus 1. So that's what it means. Similarly in Go, if you consider word 1, for now let's consider it's an array, consider everything from I to j. J here, if nothing is given, that means end of the array. So consider everything starting from I to the end of the list. And the same thing can be used to strings as well. So we are using it on strings. And one more important point, what is this dot dot dot? So this is basically used to unpack. So basically this will give you like a substring, right? Like it could be like QR or some, it will give you like a substring, like, but we can only append each individual character into this byte slice. So to extract, if you have something like QRS, to extract QRS individually, you need to unpack it. So you use dot dot dot. So it will extract each individual characters, add it to the array res. Okay. And then if j is less than n, just do the same thing. And dot dot dot. At the end, they expect you to return a string. So you have a byte-sized array here. So convert it into a string and then just return it. Let's check. Seems to work. Submit it. Okay, nice. It has 100% runtime. It's also doing very good memory wise. Why is it doing good memory wise? Because I used byte array here. Because slice are immutable. Slice are mutable in Go, and strings are immutable. So if I had something like var res is equal to like this, and if I had the looping logic here, like, I'm not going to write the logic. If I had the looping logic here, and if I tried to do like an addition of word 1 I, if I had tried to do something like this, the way it works in Go is, as I told, strings is immutable. So for every single character, it basically creates a new string. So this is like very inefficient. So if you are done like this, inefficient. So we don't want to follow a method like this because it's inefficient. So that's why we use a slice. So we create a res and then we append it dynamically and then we return it. So this way we consume less memory. So that's it for this video. Thank you so much.